Hey there, everyone! Welcome back to our channel. If you're passionate about technology, artificial intelligence, or just curious about how machines learn, you're in the right place. Today, we're diving into a fascinating topic that often pops up in discussions about machine learning, the difference between supervised and unsupervised learning. So, whether you're a beginner in the field or just looking to brush up on your knowledge, stick around as we unravel these concepts together. But before we jump in, have you ever wondered how your favorite streaming service knows just what to recommend for you? Or how your email filters out spam? Well, these are great examples of machine learning in action. So, let's explore the two main types of learning algorithms, supervised and unsupervised. Let's start with supervised learning. Think of it like a teacher guiding students through a subject. In this approach, the algorithm learns from labeled data. This means we provide the model with input-output pairs, where the input is the data we want to analyze, and the output is the result we expect. For example, imagine you have a dataset of emails labeled as spam or not spam. In this case, your algorithm learns from these examples. By analyzing the features of the emails, such as specific keywords, the sender's address, or the frequency of certain phrases, the model can identify patterns. Once trained, it can then categorize new, unlabeled emails based on what it learned from the training data. Here's a quick breakdown of some common supervised learning tasks. 1. Classification. This involves predicting a category. Besides spam detection, you might classify images of animals into categories like cat, dog, or the bird. 2. Regression. This is about predicting a continuous value. For instance, predicting house prices based on features like size, location, and number of bedrooms. Supervised learning usually requires a lot of labeled data, which can sometimes be a challenge to gather. But when done right, it can yield highly accurate models, provided the data is relevant and well prepared. Now, let's switch gears and talk about unsupervised learning. Unlike supervised learning, this method doesn't require labeled data. It's like exploring a new city without a map. The algorithm tries to find hidden patterns or intrinsic structures in the data on its own. A great example of this is customer segmentation. Imagine you run a retail business and want to understand your customers better. With unsupervised learning, you can input data like purchasing behavior, age, and location without predetermined categories. The algorithm may group customers into clusters based on similarities, helping you tailor marketing strategies effectively. Here are two common tasks associated with unsupervised learning. 1. Clustering. This is where the algorithm groups similar data points together. Think demographic segments in marketing, where you identify groups of customers based on their shopping habits. 2. Dimensionality reduction. This involves reducing the number of variables under consideration. Techniques like principal component analysis help simplify data while maintaining its essential characteristics, which is useful in visualizing high-dimensional datasets. The beauty of unsupervised learning is its ability to uncover hidden patterns you might not have considered. However, interpreting the results can be a bit tricky since there's no specific label guiding the learning process. To summarize, the main difference between supervised and unsupervised learning is the presence of labeled data. Supervised learning requires it, allowing for precise predictions based on established patterns. In contrast, unsupervised learning thrives on unlabeled data, seeking to identify underlying structures without prior knowledge. In terms of applications, supervised learning is fantastic for tasks like image recognition, fraud detection, and medical diagnosis, where historical data is abundant. Unsupervised learning, on the other hand, is incredibly useful in market research, customer analysis, and anomaly detection, where discovering new insights is crucial. Thanks for sticking with me through this exploration of supervised and unsupervised learning. I hope you now have a clearer understanding of these two fundamental concepts in machine learning. If you found this video helpful, please give it a thumbs up and share it with your friends who might also be interested in learning about AI. And don't forget to subscribe to our channel for more exciting content on technology and beyond. In the comments below, let us know what topics you'd like us to cover next. Until next time, keep learning and stay curious. Bye for now.